Here's some explanations for your Chapter 1 quiz. This is the second quiz we took for the chapter. The first question asks you to find a parallel and perpendicular line that pass through the point 6, negative 1, excuse me. And so if our lines are going to be parallel and perpendicular to the equation that's given, we have to start by finding the slope. You'll notice over here on the right hand side, that's what I'm doing. I'm taking the original problem, the original equation that they've given us. I decided to put it in slope-intercept form. I found the slope. The slope's -2. So I know right away that the line that is parallel to the given line must have the same slope, and the line that is perpendicular to the given line is going to have a slope that is the opposite reciprocal. Real important detail, something that you all should remember. But you'll notice that the slope of my parallel line is -2 and my perpendicular line is 1/2 as a result. For me, the next thing I want to do then is make sure that each of my equations pass through the point that's given. So you'll notice that each of my lines that I'm trying to create is given or set up in slope-intercept form. And all I do is I plug in 6 for x and -1 for y in each of the subsequent lines here as I'm working out my equation. When I have the intercept, the b value, as I've got it labeled, then I can simply plug back in, and I've got my equations, you'll notice, for the parallel and for the perpendicular lines. Procedurally, nothing changes, but if you had this version of the quiz, you'll notice the answers are, of course, a little bit different, because now the lines that you've got are going to pass through the point -3, 1, instead of the previous value. If you do take a look, the work that I've done over here on the side is essentially the same. I have the slope for each of my lines, whether it's parallel or perpendicular. If the line is to be parallel, you'll notice that the slopes match. If the line is going to be perpendicular, then the slopes will be opposite reciprocals. So again, parallel, they have the same slope. Perpendicular, the lines are opposite reciprocals. You can also take a look at the rest of my key steps here, but once again, I'm plugging in the values for x and y that they've provided me in order to find the intercepts for each of my respective lines. Once I've got that, you'll notice I've got my parallel and my perpendicular line to the original equation, and you can quickly verify that they do both pass through the point -3, 1. If you want to plug in -3 for x, you'll notice that you get a 1 as an output. Most of what I would tell you for number 2 is the same detail that I'd give you in class, that you really need to make sure you understand and have the values for the unit circle either memorized, or you got to be familiar enough with some of your basic trig identities or relationships so that you know some of these important sine and cosine values. You can go through and double check these if you want, if you've got a unit circle alongside. Otherwise, my recommendation is make sure that you really understand the 30-60-90 relationships and the 45-45-90 relationships that you would have learned in geometry. Those are very helpful details to review. But in this case, you'll see the values that are given. You could just as easily look them up yourself. If you have this version of the quiz, then it's cosine of pi over 6, sine of 3 pi over 2, sine of pi, cosine of pi over 3 were the values that you had to find. So if you've got any other questions, I think it'd be better for us to discuss outside the scope of this video rather than me trying to recreate a lot of different geometry and trig details for you. But definitely something that you need to understand and have memorized, or have at least a very, very good understanding about for your upcoming test. Now we're moving to the part of the quiz where you were allowed to use a calculator, and so you'll notice that some of the details here may not be as spelled out, simply because I was typing in some of these to my calculator to get a final answer. But for this first question, when it says Barry invested $7,500 in the stock market, it says his investment tanked and he lost 14% each year for the next 4 years. So notice that my multiplier that I'm using here in this exponential equation is 0.86. I don't use 0.14 because I'm translating this 14% loss. I'm saying to myself, if Barry lost 14%, then it stands to reason that he's earning or gaining or keeping 86% of his investment. So that's why there's a 0.86 here as opposed to a 0.14. So he retains 86% or 0.86 of his investment. He will get that for each of the 4 years, so 0.86 to the fourth times the initial principal value, that's $7,500. $4,102.56 is my answer, and it's appropriate here to round to 2 decimal places since we are dealing with money, and you'll notice that that is how I've written my final answer. For the second part, it's simply asking us to take this data and translate it into an equation so that if he continues to lose 14% each year, we'd like some type of an equation that we could have and plug in if we were given values for t. So it's really not a big change. All I'm doing is keeping an input here as opposed to having a specific value. So for example, if you want to know what he's got in 4 years, I plug in a 4 right here. If you want to know what he's got in 10 years, I plug in a 10, and that way I have an equation as opposed to I'm just punching numbers into my calculator each time. So that's it. If I recall, this was the most difficult statistically from the results of the quiz, the one that was the most frequently missed. In this case, I'm trying to come up with an equation or a formula that will, one, be in this exponential form. It's got a base e as opposed to another number for its base, and I'm also trying to make sure that it measures the weight of the substance since 9 a.m. So you can think of 9 a.m. as your initial time frame, or your t equals 0. 10 a.m. you can think of as t equals 1, t equals 2, etc. And so as you're going through and you're creating your equation, that might be worth noting in this particular problem, that time is equal to 0 at 9 a.m. First thing that I did was I tried to determine what the multiplier is from the 9 a.m. to the 10 a.m. time frame. And so you can do some simple division, or you can look at the data here. Since I gave you a weight that was 10 grams and the second weight was 9.225, you could simply move the decimal place if you wanted to. But in any event, once you determine the multiplier, it's just a matter of converting that number into something that's got a base e. And so what I decided to do is simply say, if this is my multiplier, I need to convert that to a base e, which means I got to find a constant value that, when used with this base e, will give me the 0.9225 as a result. This portion down here should not need much explanation in terms of the math that I'm doing. So I'll pretend that you know all the details for that. If not, we can discuss it further. But when I get a final result for k, that becomes the value that gets plugged in right there. And the initial value, which is 10, gives me my final answer. So q is equal to 10 times e raised to the negative 0.0807t. A couple of you set this up in a similar fashion, and it works just as well. Some of you decided to simply take and use something like this, where you would say, let's let q equal 10 e raised to the negative k times t. Well, t of course is 0 when we start. So I had some of you who did something like this. Boy, that writing looks terrible. I hope you can understand that that's a 0. But this, of course, simply verifies that I do have a value, or initial value rather, that's going to be 10. And so what we could do is then we could come back in and look at it as though we have 9.225 225 and set that equal to 10 times e to the negative, in this case if time is 10 a.m. we'll have -1 times k. Again, I apologize, that's a little bit sloppy, but you can do the same operation and solve this one for k. If you were to do that, you'll notice that you end up back over here, because after you divide both sides by 10, you'll have e to the minus k. There's a minus sign. It's underneath an equal sign, so it's nearly impossible to read, but my apologies. Same operation either way. Last but not least, let's solve some equations using some logarithms. There are a lot of different ways to set this up, so if you're looking at my work, you think it sucks, you would rather set it up a little bit differently, as long as you're following some of the basic log principles and you're following them correctly, there are dozens of ways you could really set this up. What I decided to do in this first case was take the natural log of both sides. I knew that since I have a base e on the right hand side and I have two instances of the variable, it's at some point I'm going to have to take the natural log of both sides so I can combine like terms. So I did that. Then I also used one of the log properties, which says if I've got a logarithm, I can take the exponent and bring it to the front, and it acts as a multiplier. These are equivalent in this case. So what I end up with, as you can see, is 3x over on the right side because the natural log of e is just 1. And then over on the left side I have to do some distribution because you'll notice that there's an x tucked away in this expression, and unless I somehow combine like terms, I'm not going to be able to solve this for x. So I decided to distribute the natural log of 18. I've got x times natural log of 18 plus 2 natural log of 18. Still got that 3x over on the right hand side. And then now it's just a matter of combining like terms. So I decided I would subtract x natural log of 18 from both sides, thinking that I've got to combine x's. And then I factor out the x. You'll see up here I factor out the x. And then I'm left with the quantity of 3 minus natural log of 18 on the right side after that factoring is done. So in the end, if you follow over here on the right, the last thing I've got here is my exact answer. X is equal to 2 natural log of 18 divided by the quantity 3 minus natural log of 18. I then decided that it might be a little bit easier for me to check my work if I get the decimal equivalent, so I tossed this natural log expression in my calculator. The decimal equivalent, or decimal approximation rather, that I get is 52.73. And I did actually put that back into the original problem just to make sure that it would balance. It did, and I got to tell you, I was just thrilled that it balanced. So I knew I had the right answer, and that was it for part A. Part B was a little bit simpler. For part B, first thing I'm going to do is divide both sides by 40. I only have one instance of the variable in this case, so I don't have as much manipulation or algebra to do. Once I divide both sides by 40, I now decided to take the natural log of both sides. Some of you took the log of both sides, which is fine too. But regardless, you're going to have to apply the same principle we did above, where I bring this x out to the front as a multiplier. And in doing so, I'll have x natural log of 1.02. This side, all I did was reduce the 18/40ths down to 9/20ths, so it's in its simplest form. And then I divide both sides by the natural log of 1.02 to isolate x. And similar to part A, I've got a natural log expression. I wanted a decimal equivalent, so I used my calculator to get that. And I did plug it back in, and negative 40.32 does balance these two sides of the equation, and it makes both sides equal to 18. That's it. Thanks for watching. If you got any other questions, let me know. Remember, we got a test coming up very, very soon. So if there are some questions about any details on this quiz, don't be afraid to ask. Good luck, and have fun studying. See ya.